All right, folks, let's get started. This is Hemant Alhans, and I have with me Vinayak Joglekar, our co-founder and CTO. Vinayak and I will take turns to cover our top 10. So let me introduce the topic first. So the topic for this webinar today is our top 10, which is actually 12 takeaways from the recently completed Agile 2018 conference, which got done in San Diego just about 3 weeks ago. And we do this every year. So this is our kind of a takeaway, very much our viewpoint, and we'll go alternate. Vinayak and I will alternate to cover our 10 topics. Let me start first with a quick overview of the conference, and we'll keep pace of these topics because there's a lot of content here, but you guys are welcome to ask any questions that you may have, and we'll just keep picking up those questions that make sense to be covered along the way, and then of course we'll leave time for questions towards the end also. So with that, the conference overview is the fact that this was just 3 weeks ago or so in San Diego with 2,300 people. This is the biggest annual Agile conference with worldwide attendees that happens every year. And if you are a regular participant to these events with us, we do this every year also, which is right soon after the conference. We share our top 10 takeaways from the conference, which is essentially our perspective of what stood out to us based on what got covered in the conference in context of the practice of Agile development across our clients and our ecosystem. So let's start on the topics. There were 20 tracks this year in the conference. Of that, those 18 were running at any given point in time in parallel. So we had to pick a choice, choose one of the 18 sessions for every session that we needed to attend. So that means we had a small sample that we are able to attend in this conference. There was one main new track worth noting, which is number 2 here, as you see, the Agile data, metrics, and forecasting. And you'll see a lot of our takeaways will come back to this one new track that got introduced this year. So with that, let me skip through the summary page and let Vinayak start with number 1 point, Vinayak, and then I'll go to number 2 and so on. Vinayak, over to you.
Thanks, Hemant. So this year, the biggest takeaway for us was the fact that the DevOps and the UX or the lean UX seem to converge, or there's this new or an old idea that got official at this point in this conference was we have heard of, or we have been doing continuous integration, continuous testing, continuous delivery, continuous deployment all these years, and that was by and large what we call as DevOps. But now to use the information or the metrics and the data that is thrown up by DevOps, consuming that is the other side where analytics and insights that the business derives from these metrics are used for decision making, and actionable decisions are done on a continuous basis. So it completes the loop that you have now a decision making step as a part of the iteration. So it's continuous governance as well. That is something that was a new takeaway, and I'll talk a little bit more about it. So going to the next slide, the DevOps pipeline is now evolved from just being the steps that you follow from check-in to go live. It now encompasses a broader span from concept to cache. So the pipeline is starting on this, as you see in this picture in front of you, with product owners getting the concept, and then inception and preparation of the requirements and validation of the assumptions and execution in the continuous delivery pipeline as we know it. All this is a part of the DevOps pipeline, and we will then there is software and there is a tool set that we will be covering which enables this possible. So yeah, Hemant, let's go to the next slide. So here you can see the full manifestation of this pipeline. So on the left hand side in the light purple color boxes, you see the component build, unit test and static code analysis steps. Then the subsystem deploy and functional testing, performance testing and all those. So this we are all familiar with. So this is what your pipeline used to look like. But now at the production stage, you have blue-green deployment. So it has been made possible with the latest microservices and the Zool and other libraries that are made popular by Netflix. It is possible for us to do blue-green deployment. So at the same time, you have multiple versions. So it's one code base, but multiple versions. So you don't branch out, but at the same time, you have two versions of the same code base live in production, and you gradually increase the number of visitors or number of users who are using the newer version and gradually reduce the number of users using the older version. If things go all right, you roll forward. If things don't seem to go all right, you can roll backward. So that's the thinking behind blue-green deployment. Similarly, you can also do A/B testing, which I'll be talking a little bit more in detail about later today. So all this is a part of your pipeline. So measuring business KPIs and then deciding whether A goes or B goes, and finally coming up with the KPI that spells success. All this is a part of your continuous delivery, continuous governance kind of pipeline. So it is truly from concept to cash. So in the next slide, we'll see the complete tool set. Let's skip this slide for this time and let's go to the next slide. So this is the tool set. So this Jenkins, so this talk was given by Juni, who is a part of CloudBees, and CloudBees are the people behind Jenkins, and they have launched Jenkins X, which is a superset of what Jenkins does. So as we all know, Jenkins does continuous delivery pipeline. On top of that, you have Jenkins X, which takes care of concept to cache. So you have components or tools that it integrates with, which includes GitHub that you're already familiar with, and also with Helm. So Helm is a packaging tool for distributed applications which are using Kubernetes and Docker. So Helm packages these applications and it makes it possible for you to deploy them just like the shrink wrapped applications we used to have, which could be deployed and installed using a simple installer on your personal computer. Now it's possible to package these applications which are distributed, and they can be, cloud-enabled distributed applications can be shrink-wrapped and installed by the click of a button. And Harbor is a marketplace wherein these applications, just the way you have App Store or Google Play, you can put up these applications in the market on Harbor, and they can be, there is a cryptocurrency using which you will be able to buy. So this is all very futuristic. So using this tool set, you would be able to, developers would be able to not only develop, deploy, but also sell their applications using the cryptocurrency on Harbor. So that's the big eye opener this time. So this is something that is very futuristic, and that got us really very excited. Go to the next one.
Okay, so our next takeaway is on this topic of Agile quantified. So and before I go through this topic, let me just also remind all of you. So each of these takeaways that we are sharing today are attributed to respective speaker or speakers in this Agile conference, and we have tried to be diligent to provide due credit. We are using their material. These are essentially our takeaways, but it is their content. So in every page of this document, which we will share with you guys, is reference to the further details, the websites, and the people behind this content. So you're welcome to follow up on any of this stuff. So that said, let's move to the topic number 2, which was essentially a session by Larry Macaron. Those of you who have not heard of him, he has done a lot of statistically rigorous work on analyzing data from essentially using 10,000 teams worth of data from Rally going back to 2011 to 2014 to tease out some key findings on Agile practice across these large number of teams. So, and done it in a very statistically rigorous way. So some of those findings are good highlights as a part of takeaways in this session from Agile Quantified. So he uses a overall composite metric for productivity for software development productivity, performance index that he calls. And there are 4 components to that. And you see some of this stuff covered in additional topics also. So the 4 components are of these performance index. One is productivity, which is throughput, meaning how much got done by a team per period of time. Second is predictability, meaning stability of that throughput, meaning what is the variability from sprint to sprint or time period to time period for a team. So that's second metric. Third is responsiveness, meaning how quickly something, when it was ready to be a story, ready to be developed, actually got done in the hands of a user or a customer. So that's time in process, responsiveness metric. And fourth metric dimension he's using is quality of output. You can use defect density, which I think he's using in this case, but you could also have used any other quality metric like escape defect and so on. So that's with those dimensions, here are the key takeaways. Actually, before I go to takeaway, let me just give a reminder, which he did to all of us, that these takeaways on quantification, you got to be careful that there's no such thing as best practices. You got to make sure in your context, for example, if you're building something new and in the MVP stage of your development, then you may have a different context and different criteria you ought to apply versus if you are in a stable enterprise class product where you have large installed base of customers. So those context is important to apply these findings. And second is these are correlations based on available data of 10,000 teams. So you got to always question causality is not implied. Correlation is all we're talking about here. So keep those statistical considerations in mind. With that, the first takeaway in the quantification topic is the team size. So these 4 colors of bars that you see reflect the 4 different indices that he's using in the performance calculation. So the orange one is quality, which is defect density. The purple one is responsiveness, which is how quickly a story got done. Blue is predictability, which is the stability of a team's output, and green is of course the productivity, how much got done in a sprint. So the key takeaway on team size is that while 7 plus minus 2 is still the most optimal team, but if you look at the next higher bar of team size of the horizontal axis, 9 to 15, that's not that far behind. So the point was that if you can, because to reduce dependencies, if you need to have bigger teams, that's probably not a bad idea to get a bigger team also. So don't feel too compelled, too constrained to 7 plus minus 2, the 2 pizza team that we've been talking about and the industry has been talking about in the past. A larger team of 9 to 15 is also just as productive at the overall performance level if that reduces the dependence. And you'll see more on that topic also as we cover the takeaways. So that's team size. The second is length of an iteration. The data seems to be that longer iterations do correlate, as you see the on the right hand side, with higher quality in this case. So don't be shy to use longer iterations. If you are in your context have enterprise class product, and therefore QA is a much higher requirement, then longer iterations are probably better. And shorter iterations are better for higher productivity, which is throughput and quick responsiveness to getting stuff done. And that in the context of if you're building an MVP and an early stage of your product life cycle, then shorter iterations are probably better. So keep that context in mind. But in general, teams using 2 weeks iteration seems to have the best overall performance. So that's good takeaway on the iteration length. The next one is on the ratio of dev to QA. So in this case, the more testers, as you see on the right-hand side, generally leads to higher performance. The horizontal axis on the left, just describe that. Leftmost bars are where you have no testers, no people who are solely testers. Developers are owning the testing of essentially. The second bar is ratio is 0.3, which is roughly 3 developers to 1 QA. And the next bar is for between 0.3 and 0.6, so round numbers between 2 developers to 1 QA ratio. And then, of course, 1:1 is the final last bar. So with those ratios roughly in mind, more testers lead to better quality, which is, of course, seems pretty commonsensical. But if you look at the productivity, more testers also lead to lower overall productivity and responsiveness. But the teams that self-identify as no testers have the most variability in the quality, as you see in the bar. But the explanation here is that they also has almost as good a quality, probably because developers end up owning quality in those cases. So that's an interesting takeaway on the dev to QA ratio. The next version on the quantification topic is the estimation process. So again, he teased these findings from the 10,000 teams, and looks like the teams which follow what he calls a lightweight scrum, essentially just using story points, seem to have the best overall performance. And teams that use full scrum is defined as you have both story points and task hours form of estimation. So that's that takeaway. And the next one is data on co-located versus distributed teams. So the takeaway here, of course, in the horizontal axis is on the very left, you have single open space where the entire team is sitting in one open space kind of his configuration. And all the way to the right is widely distributed team across all the time zones, more than 3 hours away and all that, which includes distributed teams. Just like in our case, you have teams in India or for that matter, Eastern Europe and all that, and US. So the takeaway here is teams distributed within the same time zone. If you see the sort of the middle highest bar in the same time zone seem to have the best productivity overall. And that's a statistically rigorous finding. So like I said, I'm only sharing those pages which have statistically rigorous findings that Larry shared. And related takeaway here is if you pay attention to the extreme ends of these bars, even the most distributed teams seem to be not that far behind in terms of productivity versus the single open space layout. So that's kind of interesting finding, at least in our context of where distributed teams are pretty much the norm. And the final one is the stability of team and dedicated teams. So you use the metric on the horizontal axis of how stable and dedicated teams are. So without going into that detail, the main takeaway is stable teams result in 60% better productivity and 40% better predictability on those 2 counts. And the other takeaway is the fact that even looking through the data as he looked through of these 10,000 teams, it is pretty common that 1 out of 4 team members change every 3 months. So a certain level of churn seems to be pretty much the case, the norm across the board. So with that, let me turn it over to Vinayak for the third takeaway.
Yeah, so the third takeaway is about monoliths versus microservices, and this was by Ryan Bergman. It has become very fashionable to move to microservices, and a lot of companies are now abandoning their monoliths and turning to microservices. So before they do that, they should take a hard look at their monoliths and what are the good things that their monoliths can accomplish without moving to microservices, because it's moving to microservices is it's a fairly complex things because you're, you have multiple servers, multiple pods, multiple containers. You require traceability with distributed applications, monitoring. So it's a very different ball game. So before you get into those complexities, it's time you take a hard look at your monolith. There are some good things about your monoliths. The first is that monolith can communicate 45 times faster because you are not using HTTP. You are not over the internet. You are internally communicating within the same CPU. So a method call going from method A to method B is 45 times faster than a web service or a microservice A invoking microservice B. Also, moving code and changing dependencies is much more easy than as compared to in the case of microservices. Finding dependent code is fairly easy. What I generally do is I just make a compiler error forcibly and see what else fails to compile, and that gives you the dependent code. And finding dependencies in microservices world is much more difficult. Tracking and monitoring, it's so easy because there is a single timeline, and you can just look at the log and you will be able to track and monitor what's going on in your application, in the monolithic application. But whereas in microservices, you have multiple servers running in parallel, so there are multiple timelines. So you have to have correlation IDs and you have to extract those correlation IDs. Then only those logs would be meaningful. Adding new features is again easy, though after some time it adds to your technical debt. So that is these are some of the positive things they should look at before moving to microservices. And of course, there are these advantages you have on the right hand side that, it's easy to scale microservices. You can keep things clean and not become a ball of mud, which becomes very difficult to maintain after some time. And if you have a small change to deploy it and you want to see it by today evening, you can do so using microservices. Whereas in the case of monolith, you will have to wait for 2 weeks or 4 weeks for the release. And of course, dealing with technical debt, it's a much cleaner way that you can deal with technical debt in the case of microservices, because small changes are easy, so you can do small refactoring. Let's move to the next slide, where we talk about what you can do with your monolith before you start moving to microservices. So number one thing that you should do is you should group code by features instead of framework. So the old way of having an n-tiered architecture you see on the left-hand side, like you have front-end, middleware, and back-end, should now be changed to having a vertical sliced kind of structure where you have feature-wise structure of your code. So sign up, search, and order these vertical slices should be your code should be logically divided into these slices. Moving to the next slide, the code also can be isolated by bounded context. So there is this very well-known book by Eric Evans that talks about domain-driven design. The name of the book is Domain-Driven Design, wherein he's advising you to separate your code based on the bounded context. Each bounded context, imagine it's like a organization in which you have separate departments. So that is how you should organize your codes. For example, you have a shipping subdomain, and then within that you have a delivery domain model and a packaging domain model. So separate these out based on what functionality they are serving or what departments they belong to. So that's the logical way of dividing your code by bounded context. The third way of doing that on the next slide is isolating by dependency inversion. So dependency inversion is like having an interface talk to another interface. So you have the bulb interface registering with the button interface and letting it know that there is a listener listening to the button's event, and on event and off event will be listened to by the interface, and then that is how you separate the concerns instead of having a hard dependency where in the switch is continuously has to communicate its event and talk to the bulbs, and it has to know who all are listening to it. So there is no hard dependency in the second case. It's the standard way of dependency inversion, which we all are familiar with. So this is another way of separating out your code. So finally, with all this, going to the next slide, you will be able to package them separately using jars in Java or Ruby Jibs if you're using Ruby, or Python package index, or Microsoft NuGets, depending on which language and platform you're on. And then you would be able to, so that's the logical way of taking your monolith and then isolating the code and extracting and packaging it. And that's when you're ready to move to microservices. So if you have a bad monolith, you can't graduate from a bad monolith to a bunch of good microservices. It is advisable that you take a monolith which is having a lot of dependencies and then isolate the code the way I described, and then consider moving to microservices. So that was the takeaway in this third one.
Our next takeaway was this topic of estimation, which is a big topic always with with almost all client situations. So this was a session or sessions by Adam Uret and Troy Magenis. So the main takeaway is this point that while there is a value in the process that teams go through when they go through the exercise of estimating how much time a project or a feature will take and or how much it will cost, of time and cost estimation effort actually that goes through, while there is a value in that process because a conversation happens, the developers question each other, and QA people are and the entire team is kind of discussing why someone feels it is a 1 point story while the other person thinks it may be a 5 or a 13-point story and all that. So that conversation is very valuable. The actual output of that exercise estimate, which is cost or time estimate, is not that useful. So a better way to come for management purposes, if you want to arrive at the time or cost estimate, a much better way to do that is to use statistical approach to estimation. So I've given a link here. Of course, you can look up this website that I've where the spreadsheet resides. So Troy and Adam have made the spreadsheet available. So before I get to the spreadsheet part, let me just describe the reason. The reason is we see in this page, this graphic, again taken from Troy's keynote address on this topic also in this conference, that when a developer says that a story is 1 point, what they're actually saying, if you see in that orange part of the chart or the graphic here, the solid blocks is the time that they would need to spend to build or develop that story essentially. And similarly, a developer, when they say on the right-hand side it's a 13-point story, they're also accounting for the bigger blocks, in this case of solid blue, the time it will take for them to do their part. In reality, what actually happens is that you have plenty of wait time between something that is done by a developer versus what they need to get validated from, or they're accessing some additional functionality which is dependent on another developer, another team and all that. So there are a lot of wait state and dependencies which are not usually accounted for in individual story point estimates that a developer or a QA person does. So in this example, the two stories, one with 1 point, other with 13 points, still got done in 20 minutes because of the variability of the wait times and dependencies. And that's the inherent nature of that estimation exercise. So this is what happens even if you have a high-performing kind of a developer or a team or even a story which is, it can't, if it is blocked by other dependencies and wait times, it can't get there. So this is a good graphic that he used to illustrate that point. So instead, a better way is to use this simple spreadsheet that he's put together, which is public domain. You guys can all access it. And let me just walk through the simple inputs this needs. So you put in your start date, which in this is 4/1/15 in this example, and how many stories you have remaining to be completed. So in this example, between 20 and 30. and then you also put in, based on empirical data, what kind of a split ratio you've had when you do backlog grooming in your projects to typically a story splits to 2 or whatever, 1 to 1.5, whatever the numbers are. Again, use empirical recent data, and I'll talk more about that in a minute. In this example, this is 1:1. And then use empirical data on the recent throughput of your teams. So in a per week, in this example, if your recent data indicates the number of stories got done are between 1 and 5, and that's the empirical data you use. And then once you put that into a spreadsheet, the spreadsheet does the heavy lifting of doing a Monte Carlo simulation, and behind the scene, it is using the Weibull distribution, probability distribution function, essentially, which is more appropriate for software development process. On this page on the right-hand side, you see it is using that shape with a shape parameter of 1.5. And all that is built into the spreadsheet, so you don't have to, but if you worry about it. But if you want to read more, you can, of course, I've given a reference here. You can go to the website I said in the first page and look at this. But the net outcome of the spreadsheet simulation is, as you see on the left side of this page, is at 90% confidence likelihood you can say that this full project will get done in 11 weeks. And that's a much more robust and reliable way for management to arrive at a time and cost effort than just adding up the story point estimates and all that. So that's a better technique for estimation. And here's a little more evidence. So use empirical data, like I said. So the value of additional data diminishes very quickly. So at between 10 and 12 samples, as you see in this chart from Troy, are sufficient inputs into this spreadsheet. You don't need large amounts of data. And in fact, as I'll repeat again in a few minutes, we'll use more recent data for inputs into the Monte Carlo simulation that I referred to. And net is, just use historical velocity data or throughput data, most recent sample, and don't bring in a lot of old data, because the older data may actually be more hurtful because it has prior older context. Your different team was there or different project and all that. So just use recent data as far as possible. So that's, with that, let me turn to Vinayak for the next one.
Yeah, so the fifth takeaway was by Joe Wallen from the Safe Agile, Scaling Agile company. So we often have innovation projects in companies and they're vying for limited budget, and you have to make hard decisions whether the budget should be allocated to a project or some project that needs to stop or needs to change its direction. But such decisions are very hard to make because very often we don't take such decisions based on innovation accounting, and responsibility is not, people are not held accountable as such. It's done by some other means, like HIPPO is the highest paid person's opinion, or squeaky wheel is the other way, which is the noisiest person gets the most, or FIFO, wherein someone says that, look, my idea was the first one, so it should get the budget. So there are these not so rational ways of deciding how budget gets allocated in innovation projects. Instead of, and sunk cost must be ignored in this, because we very often have a logic saying that, hey, we have already spent $1 million on this project. Now we need to continue spending on this because we have already spent so much. So we can't really use that as an argument. We must ignore sunk costs. So these are some of the lessons that are important for us while comparing projects to decide where the money should go. If there is a metric, as someone in the last conference has said, I think it was Dan Rennertson, that if there is a metric that you would like to measure is the cost of delay. Cost of delay factors in a number of parameters. One of them is the business value. The other is the time criticality. And lastly, it's the risk reduction or opportunity enablement value. So overall, cost of delay is a good indicator of the value you're getting by building or doing certain project, and divided by the job size, which will give you the measure of the value versus the cost. So that is the way you should be you should be measuring. So it is the WSJF is the measure which will decide whether you should go. So looking at this framework which was proposed, this framework is important because the old methods of discounted cash flow such as NPV or IRR are insufficient to measure the risk in complex projects. So instead of that, you use this framework where you continue till you build an MVP and then evaluate the MVP by seeing what is the cost versus the value, and keep fine tuning and keep persevering till you find that the WSJ determines otherwise. When you see that the expected value that you're getting is less than the money that you're spending, that's the time you should stop, no matter how much your money has already, what is the sunk cost. So it has to be, decisions have to be made on that rational basis. So uh, predictability, fast feedback, ability and willingness to, what is more important is the willingness to pivot or to persevere, and the lean and agile way of budgeting. These are the four cornerstones of business agility. Moving to the next slide. Uh, for innovation accounting, we should take into account leading indicators instead of lagging indicators. So ROI, revenue, etc., they are mainly lagging indicators. They can't be used to prioritize projects. Uh, but the harder part is that leading indicators, there's no standard such as ROI, right? So you have to, depending on what the project is about, find out something that is an indicator. It is that one metric that matters, which changes from time to time, and you might get attracted in this case by a vanity matrix. So you have to ensure that that doesn't happen. So in this picture that he has shown for the airline MVP, you have leading indicators such as what is happening to the average call center volume. So if your website is getting more traffic, as you can see in the purple colored line that is going up, the blue colored line goes down because the number of people calling in to book their flights or find schedules is going to reduce. So the leading indicators are the ones which will determine whether the pivot should happen or we should persevere. So that's the main takeaway in this. So with this, let me turn to Hemant for the next takeaway.
Yeah, so our next takeaway was this topic of value over cost. So this was by a session, and most of all takeaways are we attributing to a particular session, but many times they're also corroborated by other sessions, like the case here. So, but the main idea was from a session by Chris Sims. So the idea is that most teams tend to spend way too much time in the part of cost and effort estimation, and not enough time on the value estimation part of the scope or backlog. So the better thing to do, so he suggested this idea of value estimation. So one simple technique to address this gap is to, just like teams get together and do planning poker exercise to do cost estimation or time estimation for the scope of work or for a sprint, what to pull into a sprint, what is important is to maybe do a similar exercise where you have a session which is now, instead of the team attending the session, you have all the stakeholders who are doing a value estimation exercise in a planning poker like sessions, and you use the same deck of cards, the Fibonacci series card or the modified Fibonacci series card, whatever you use the same deck of cards, but this time you have, let's say you have 30 or so stories in your backlog. Let each stakeholder, the stakeholders could be executives, salespeople, whoever is the key stakeholders who bringing the voice of customer to articulate the value of that project, you have them force rank first all these, in this example, say 30 stories, and then have them go around and assign the point cards, whether it's a 1 point, but this time the points imply the value, business value, whether it's a 1 point or 3 point or 5 point or 8 point, whatever the numbers are, and let them do the debate and discussion why a certain feature or a story is a 5 point, and a salesperson may say, oh no, this is a 13-point story because I could close a deal next quarter or this quarter based on this feature, and so on. So those are all very helpful discussion, and end of that exercise you'll essentially have value points, just like you have story effort points for each story. And do these two exercises, the estimation exercise of effort, completely independently with the team versus the value point exercise that we're describing here with the stakeholders. And then you get to the final prioritization, and of course use a commonsensical approach of where things which are high value based on this exercise and lower cost of story point, those are quick wins. Those ought to be prioritized the highest to get done. And things which are high value but high cost, those are the good candidates to break down those stories into smaller stories. So this is a good concrete way to get to that. This is just a pictorial illustrating how we did that, those story points on various features, in this case for remodeling a house as an illustration. With that, over to you, Vinayak. I'm going to skip the next few pages as illustration here.
So we have covered Lean Startup, and many of you might have read the book by Eric Ries on Lean Startup. It's a big movement by itself. There are Lean Startup conferences happening. So this particular session by Jürgen Appelo was talking about a startup that he is doing, and he's writing a book parallelly of his learnings. And what he said was there's much more to a startup than Lean Startup. So Lean Startup methodology is talking about building a minimum viable product, measuring and learning from the failure, and then pivot or persevere. So there are so many other things that you do. So this innovation cycle that you see on this starts with conceptualizing, and it combines the ideas of the empathizing, synthesizing, and hypothesizing, which come from the design thinking community. So empathizing is going and observing customers, synthesizing is increasing and decreasing, so converging and diverging number of ideas, and finally forming a hypothesis before you build a minimum viable product. So going to the next slide. Can we go to, yeah. So this other learning that he has is that hiring is not really covered in deep detail in the Lean Startup, but hiring for a startup is tougher than raising capital, getting the right people, getting the right team. So he experimented, and he created a team which by hiring globally. So the right people, no matter where they are, there's no office, so they can work from home. That guaranteed diversity, no stand-up meetings. They have a daily cafe which is recorded, so it starts with 5 minutes of chit-chat, and then they have some kind of voting on topics that they need to discuss on that day, and then they have lean coffee style discussions that is recorded on video for record. And periodically, the money that they save on not having the office is spent on going or taking the team out to an exotic location where they meet, and then they have their bonding and team building. So that's the way they have organized, and that seems to work pretty well for them. So this, again, I have covered in the year before in one more. So there was another company called Automatic, the makers of WordPress. They are also having a similar way of working. So going to the next slide. The other innovation they had was crowdfunding. So they got this Jürgen Appelo startup funded by crowdfunding platforms. So in this you can see the crowdfunding platforms that he has used: Foundation, Seed RS, Investor, etc. And he has been able to get these 100 or so people who were participating and who bought in as a part of the crowdfunding. They became their active advocates of the product. So that's the biggest advantage of going the crowdfunding route. The other takeaway was that going the VC route is unagile, because once you sign up, once you're sold the story to VC, it's hard to change directions, and that is against the agile principles. Now, just as a tip, crowdfunding, those of you who are considering, charge 5 to 10%. Those platforms charge 5 to 10%, but which is worth it. And finally, some golden nuggets by Jürgen Appelo. So most startups fail because they start scaling without validating, which is a very important takeaway. So you have to take time to stabilize after validation before you start scaling. And in the next page, you will see the traditional lean canvas, which on the next page, you'll see the traditional lean canvas, which was what was proposed by Ash Maurya in his Running Lean book. So in this, you have waterfall steps that one follows to go from step number 1, problem statement, step number 2, recognizing the customer segments, and so on and so forth. Instead of that, he realized that it's not a really a step-by-step process. There are some overlaps. So instead of that, going to the next slide, what Jürgen Appelo proposes is something like this restructured lean canvas, which looks more like a Gantt chart where there are overlaps. So it's not like one process ends and the second starts. You have a process running, several of these processes that are running in parallel. So that was the main takeaway from Jürgen Appelo. Quite an interesting addition to the lean startup thinking. With that, I'll turn to Hemant for the next takeaway.
Yeah, so our next takeaway on this was this topic of Scrum at scale. So of course, this topic gets covered every year, and the takeaway this year is this new framework or approach by Jeff Sutherland, who is a co-creator, as most of you probably are aware of his name, of Scrum. And he also offered a much lighter weight scaling framework. While so SAFe, those of you who are familiar with Dean Leffingwell's scaled agile framework, SAFe, which is, by market share or awareness, the most dominant one, but it gets some flack for being a little too heavy to be truly agile. So some people criticize that SAFe framework to be just essentially a waterfall with agile-friendly terminology. So regardless of where you fall on that thought process, the Scrum at Scale by Jeff Sutherland promises to be a much lighter weight way of scaling agile across large number of teams, and it got significant new coverage, recent coverage in both Harvard Business Review and of course his own new Scrum guide for Scrum at Scale. The main idea here for Scrum at Scale by Jeff Sutherland essentially is the fact that you have to do linear scalability using lightweight approaches. The linear scalability idea is that both operationally, so he defines essentially 2 cycles here: a Scrum Master cycle, which is efficiency of delivering stuff linear scalability of delivering stuff, and the product owner cycle on the right hand side, which is the linear scalability of the business value. And the emphasis is a lot on the right hand side, which is the product owner role, which is ruthlessly prioritizing stuff and working on the highest value stuff. And overall, the mechanism he's suggesting are Scrum of Scrums and Scrum of Scrums and all that, and then these cross-functional teams of executive action team and enterprise meta Scrum teams to resolve any dependency issues and essentially net reduce what he calls the decision latency, which is making sure the product owner can respond quickly to drive the process efficiency. You can read more about, of course, in the public domain white paper. So with that, let me turn it over to you, Vinayak.
Yeah, so this is extract of 3 sessions by Christopher Lucy and Jenny Wanger and Ian Maple. So the first one by Ian Maple, Hemant, go to the next slide. So this is the Design for Delight program that they have at Intuit. So They have 3 steps that they follow. The first one is striking deep empathy with the customer. They actually visit customers, they follow their customers home, observe them, take notes, take photos. There are some tips like when you are asking questions, you have to ask clarifications, actively listen, don't suggest, act like a dummy. Then once you have empathized with the customer, that's when you start getting ideas. So then you go broad, you generate as many ideas as possible, and then you go narrow by having a 2x2 kind of grid. So each grid you can imagine is like a window with one vertical axis and one horizontal axis. So on vertical axis you have a orthogonal word like speed, and on the horizontal one accuracy. So high speed, low speed, high accuracy, low accuracy, etc. And then those ideas which are in the right hand top quadrant are the ones which you will go forward. That is how you will narrow the ideas to ideas which are more that need to be pursued. So that is how you go broad and then go narrow. A/B testing. So the main takeaway here in A/B testing is that whenever there is an issue that you may face, like many times we have issues in the environment, such as maybe weather, or maybe there is a competitor running a scheme or a promotion, because of which you always rationalize that, look, I ran this experiment, I ran this test, but it was not as successful as I thought because there was this thing that the rain happened, or because there was this traffic because of the game, or so on and so forth. So with A/B test, the good part is that you're running both A and B at the same time. So if it rained for A, it rained for B as well. So your tests are still valid. You don't have to run the tests, or you don't have to rationalize. So like even if there is a bug that exists for A, and that same bug exists for B. So you don't have to, your test is still valid. So that is the main advantage of doing A/B testing as compared to just doing hypothesis-driven testing using a line in the sand. So that is the main takeaway. With that, I'll let Hemant talk about the 10th takeaway.
Yeah, so next takeaway was this topic of myth of 10x developers. It's a session by Adam Uret, and I won't go to the actual experiment. You guys, if you have not seen it, I highly recommend looking through this red bead experiment. But the net takeaway is that people, your teams, your developers, your QA are working in a system, organizational system, and the variations exist within that system. The individual performance will vary based on the dependencies and the nature of the system. And the individual performance and rewards and penalties actually don't work, and which got demonstrated by this red bead experiment. And he also shared this chart, which is the example where if flight performance of a pilot is, if you praise a good performance, his or her performance drops, it was noticed, and if you criticize, then the performance improves. Then ultimately, if you look closely at the data, the net conclusion was it was just regression to the mean. So it was not a very effective to worry about individual performance unless it is out of certain control ranges. So that's the takeaway here, and this is an example of a 10x developer having depending on a much larger performance of an individual is just not realistic in the context of an overall system. So think of the system performance rather than individual performance. Over to you, Vinayak.
Yeah, so last time we had covered the chaos monkey that randomly shuts off servers. So this time we talked about simian army, which is an entire army of monkeys. Going to the next page, let's talk about each one of the characters in this army. So as you know, chaos is one which kills random instances. Chaos gorilla kills entire zones. Chaos Kong kills regions. Latency degrades networks and injects faults. Conformity looks for outliers. There are some good ones also. Not all monkeys are bad. Circus kills and launches instances to maintain zone balance. And doctor fixes unhealthy resources. Then there is janitor. Janitor will just clean up dead instances. Howler will just inform what's going wrong and what needs to be corrected, but does nothing about it. And security is something that runs security tests. So with that, so chaos engineering is not just about shutting down servers, but it is, you have to have a hypothesis. You have to start with an expected behavior. What happens if the entire city loses power, for example? With this hypothesis, you will start working, and then its impact on various servers, and so also there could be things which are human in nature. For example, if there is a particular person who's likely to commit certain mistakes or errors, make that as a assumption or as an experiment and run that experiment. If somebody checks in bad code, or somebody breaks something, or somebody deletes a file, then what happens? So have these hypotheses which are realistic, and then the second thing important that we talked about was limiting the blast radius. So don't let this experiment run out of hands. So keep the radius limited to a certain controlled zone, and start by testing the weakest link. So these are some of the takeaways of chaos engineering and recommendations here. So with that, I'll let Hemant go to the last one. Yeah, I think we are running out of time.
Yeah, the final metric as we rush through this is the topic of Agile metrics for your Agile team. So there were many sessions that covered, and I mentioned in the beginning there was a full track actually this year, new one on this. So the main takeaway on this was you got to have balanced metrics of these four key dimensions. One is quality. Again, they're in no particular order. Quality dimension, which is how well the stuff got done, whether you use defect density or escape defects, use one or the other. One metric on quality. Use one metric on productivity, how much got done, which is throughput or number of story points or stories got done and all that. Use third is responsiveness, how quickly something got delivered, value got delivered. So cycle time or lead time, whatever, pick one. And then fourth, some sense of stability, predictability of the team, variability from sprint to sprint and all that. So you can use either the standard of deviation or whatever metric you use. So use these four. So these are balanced set of four metrics, but look at the trend. So look at trend rather than individual snapshots, and that's the best way to measure a team. And here an example, a dashboard for where you have a trending of each of these. So that way you will have much better perspective. And this next page, as I skipped to, is another example where this is not from Agile 2018. I found this very helpful from a different source, but the same, a general idea. In this case, they incorporated team health also as a part of one of the four things that they accounted for. Net essentially is this advice from Troy Magenis, who has given a lot of thought on this topic, is that use trends, not numbers. Team, not individual, for metrics, and multiple metrics, not a single metric, because single metric can be gamed, and apply in context. And this we repeated. So that's we'll skip to the other pages of other takeaways here today. So that's essentially our kind of overview of top 10 takeaways. I guess we have 2 minutes for questions. So let me do a quick introduction to Synergip, and I'll at least take one question at the end. So those of you who are unfamiliar with Synergip, we are your trusted Agile software co-development partner. We emphasize the topic of co-development. We are essentially an extension of our client's team, and we offer these value prop, which is we accelerate what we deliver, help you accelerate the delivery of your product or technology roadmap, and then address any skill gaps, whether it's the DevOps or machine learning that you may have in your in-house team. We can help you cover those skill gaps, and then while doing that, we'll save significant cost advantage because we have teams in India, and then of course we have teams in US to help ease the process of collaborating with your in-house team. And we work with our clients throughout their product life cycle, whether in the early MVP stage or in the growth phase or in the maturity phase or in the maintenance and support phase. And next page just gives a quick glimpse of our clients. It's a crowded page, but just gives you a glimpse of some of our clients. Some are bigger companies, some are smaller companies, but that's the mix of our clients. Most of them are software product companies. So with that, let's come back to taking at least one question. I'll take right now, in the interest of time, we will take that final relevant question. So we will make these pages, this document available through our website. I think we have done in-person events, and this is the webinar format for these top 10, 12 takeaways. And so you will have links and document details that you can follow up on any of these takeaways, and we'll be happy to answer any questions separately if you guys have. So with that, I think we are done for this session. Thanks folks for joining, and stay tuned for our next month's webinar, which is will be announced shortly on our website. Okay, thanks.
Thank you.